Bismillahirrahmanirrahim. Sallallahu alayhi wa alayhi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alayhi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of P1 variant 1-3 of June 2020. And for this, I am using the work of an outstanding and one of my best student, Miss Umama Khan of class 2022, the Lyceum. All these instructions are very important, especially this last one. Give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles in degrees, unless a different level of accuracy is specified in the question. Must follow all these instructions. An important advice for me and for everyone: we must avoid backbiting. 2 very important tips to solve the paper in a good way. Number 1, read the questions carefully. Number 2, avoid careless mistakes. Question number 1, find the set of values of m for which this line and this curve intersect at 2 distinct points. Well, 2 distinct points means b square minus 4ac greater or equal to 0. Number 1, we need to equate these two y's to get the quadratic equation. Here we equated both the y's and we got this equation. Now by comparing this quadratic equation with the standard quadratic equation, which is ax square plus bx plus c, we can have the values of a, b and c. This is a, this is b and this is c. By substituting the values of a, b, c into this discriminant, we have this inequality. By simplifying this inequality, we have this inequality. Now by breaking the middle term, we have this. This is the completely factorized form of this inequality. Since we have greater equal to sign, so the required region is above the origin. These are 2 required regions. So n is greater equal to 8 or n is less than equal to minus 4. This is the solution of this inequality. Question number 2. The equation of a curve is this. It is given that the point 4, 7 lies on the curve. Find the equation of the curve. By integrating this equation, we can get the equation of the curve. So when you will integrate dy, it will become y. 3x power half will become 3x power 3 upon 2 divided by 3 upon 2. And this will become minus 3x power half divided by half plus c. This is the simplified form of this equation. By substituting this point into this equation, we can get the value of c, which is 3. Now substitute c back into this equation to get the equation, required equation of the curve. This is the equation of this curve. This question is of transformations of functions. In each of parts A, B and C, the graph shown with solid lines has equation. This graph and this graph. The graph shown with broken lines is a transformation of y is equal to f of x. State in terms of f the equation of the graph shown with broken lines. You just need to observe this transformation. This is reflection of this graph about y-axis. Therefore, this graph has equation y is equal to f of minus x. Because when you reflect anything about y-axis, you change the sign of x coordinate. Therefore, we have minus here. Now observe this transformation. This is the stretch of this graph with x-axis as invariant line. And the stretch factor is 2. The formula of stretch factor is this: image to invariant line distance divided by object to invariant line distance. So image to invariant line distance is 2, whereas the corresponding object point to the invariant line distance is 1. therefore stretch factor is 2, and this is the equation of vertical stretch with factor 2. This is simple. This is just translation of this graph with vector -4, -3. This is -4 and this is -3. So the equation of this graph will be y is equal to f of x plus 4, write the opposite sign for x coordinate, horizontal coordinate component, and same sign for vertical component. This is the rule. We have -4 here, so write +4 and copy this -3 here. This is the equation of the resulting graph. Question number 4. Expand 1 plus a whole power 5 in ascending powers of a up to and including the term in a cube. This is simple. By using binomial theorem, we can easily expand this. So 1 power 5, 5c1, a to the power 1, 5c2, a to the power 2, 5c3, a to the power 3. Just simplify this carefully. This is the expanded form of this expansion up to and including the term in x cube, a cube. Hence expand this. Now by comparing these two expansions, you can easily see this, that this a is replaced by x plus x square. So you just need to replace, let me write this here. A is replaced by x plus x square here. So you need to replace this a by x plus x square here, here, and here. And by simplifying this expansion, you can have this result. You need to expand this, but you just need to get the first term from this expansion, because you need the expansion up to and including the term in x cube. Don't expand this completely, just take out the first term. When you will expand this first term, this will become x cube, so 10x cube. You can expand this fully, but you have to take the selected terms only. You have to ignore the last term, which is x power 4. You just need two terms from this expansion, which is x square and 2x cube. This is the final answer. This is important. Make sure you just take the first term from this expansion, and you just need to take two terms from this expansion, first two terms. You don't need to take this term. Just take this and this, and give your answer in ascending powers of x. Question number 5. The diagram shows a cord going around a pulley and a pin. The pulley is modeled as a circle with center O and radius 5. The thickness of the cord and the size of the pin P can be neglected. The pin is situated 13 centimeter vertically below O. This is the pin. Points A and B are on the circumference of the circle such that AP and BP are tangents to the circle. So these triangles are congruent, because tangents from external point to circle are always equal. Calculate the length of the cord. So we need this length, this perimeter. In fact, we need this thing, this arc, and these two lengths, because this will make the total length of the cord. First, we need to work for this arc, and for that we first need to work for this angle. And we can easily get this angle by using tan theta or cos theta in this triangle. So by using cos theta in this triangle, we can have the angle. So we can easily get this angle by using cos theta in this triangle. This is hypotenuse and this is adjacent. So this angle is 1.176. This is also same, this should be 1.176. So by subtracting these two angles from 2 pi, we can get this angle, which is 2, which is, you don't need to equate this or simplify this. This is fine, 2 pi minus 2.352. Now we can easily get the length of this chord, this arc, which is S is equal to r theta. This is here, this angle is here, this total angle is 2.352, therefore this angle is 2 pi minus 2.352, it's here, and this is the formula of arc length, r theta. Therefore the length of this arc is 19.65. Now we need to use Pythagoras theorem in this triangle to get this length. This length is 12. Now the perimeter of this chord will be 12 plus 12 plus this length. This is the final answer up to 3 significant figures. Question number 6. A point P is moving along a curve in such a way that the x coordinate of P is increasing at a constant rate of 2 units per minute. This is dx upon dt, 2 units per minute. And this is the equation of y. We need the rate of change of y coordinate when x is 1. So we have to use chain rule for that. So first we need to differentiate this with respect to x. At x is equal to 1, we can get the value of dy upon dx. So when you will differentiate this with respect to x, you will get this thing. At x1, the answer is 5 upon 4. This is the formula of chain rule. We need dy upon dt, we have dy upon dx, 5 upon 4, we have dx upon dt, which is 2. So the final answer is 5 upon 2. The next part of this question. Find the value of x when the y coordinate is increasing at 5 upon 8 units per minute. This is simple. By using chain rule formula and this expression of gradient, we can get the x coordinate. This is the chain rule. This is dy upon dt, this is dx upon dt, and this is dy upon dx. Just need to solve this equation for x. When you will solve this equation for x, you will get x13. Question number 7. Show that this identity, this can be expressed in this way. So by taking this left hand side and taking LCM, we have this thing. So by simplifying, in denominator we use the formula a plus b, a minus b. So a square minus b square, this will become sine square theta. In numerator, by simplifying these two terms, we have this thing, and by cancelling these two terms, we have 2 tan theta upon sine square theta. You know tan theta is sine theta upon cos theta. So tan theta is sine theta upon cos theta divided by this sine square theta. By simplifying this equation, we can get the requirement, which is 2 cos theta sine theta, 2 upon cos theta sine theta. You could even take tan theta common from this. If you could take tan theta common, this would become simple. We could do this question in this way as well. Both methods are right. Hence solve the equation. So we will first replace this by 2 upon sine theta and cos theta. By cross multiplication, we have this equation. Tan is sine upon cos. We need to bring cos here. Then we need to bring 2 sine theta on this side so that we can factorize this equation easily. So finally we have sine theta equals to 0 and this equation is equal to 0. So cos theta is plus minus 1 upon root 3. Cos must be in first and second quadrant because of this domain. So these are the answers for cos theta. Sin theta is 0 at 0 degree and 180 degree. But both the answers are not included in this domain. So we need to reject both the answers. Therefore, the final answers are 54.7 and 125.1 degree up to 1 decimal place. Make sure you will give your answer 1 decimal place in degrees when answers are non-exact. Next question 8. The first term of a progression is sine square theta for this domain. The second term is this. Given that the progression is geometric, find the sum to infinity. You know, r is t2 upon t1. So by using this formula, we can get r. So r is cos square theta, and sum to infinite formula is a upon 1 minus r. So by substituting the values of a and r into sum to infinite formula, we can get this thing. And you know, 1 minus cos square theta is sine square theta. So sum to infinite is 1. It is now given state that the progression is AP. Find the common difference of the progression in terms of sine theta. You know, the formula of D is T2 minus T1. So this is T2 and this is T1. So by using this formula, we can get the value of D, which is minus sine power 4 theta. Find the sum of the first 16 terms when theta is pi by 3. This is simple. We have A, we have D. We can easily get the sum. So the sum formula for Sn is S16. Sn, n upon 2, 2a plus n minus 1d. This is the sum formula for AP. So 16 means 16 here, 16 upon 2, a is this and d is this. So by substituting the values of n, a and d into Sn formula, we have this. Now we just need to simplify this one. So we need to put theta pi by 3 here and here. You can write this power as whole power, because if you have sine 4 theta, then you can write this as sine theta whole power 4. Therefore, sine pi by 3, the answer of sine pi by 3 is under root 3 upon 2, and after squaring, you will get 3 upon 4. Finally, you will get 12. In the same way, you can get the value of this. This is 135. Let me correct this. This is not pi. This is 135 upon 2. So finally, we have this number or this number. Question number 9. F of x is this for this domain and g of x is this for this domain. Express f of x in the form. By comparing the coefficient method, we can easily express this into this form. This is equation number 1. See, the coefficient of x is minus 2a on right hand side and is minus 4 on left hand side. So minus 2a is equal to minus 4, therefore a is 2. these two terms are constant and the constant term is 3 here. So AB is minus 3. By comparing these two with 3, we can get the value of B. Make sure you will substitute the values of A and B into equation 1. This is the final answer. It is given that f is a 1-1 function. 1-1 function means f has an inverse. So according to this domain, see, this is the domain of function f. So according to this domain, this is the rough sketch. This one is the rough sketch of this function with turning point 2 comma minus 1. So the domain of this function is greater than 2. By comparing this with the given domain, we can get the value of c. C is 2. It is now given that c is 5. Find an expression for f inverse. Number 1, get the range of f with respect to this domain. When you will substitute 5 here, you will get 8. So this is the range of this function f. Now f inverse. Replace, you need to separate this bracket first and then you need to take a square root on both sides. When you will take a square root, you will have two signs, plus minus. You have to take the plus sign because x is increasing. Since the domain has greater sign, so you need to take just a plus sign. This is the expression for f inverse. And its domain will be the range of this function. You all know the range of f will become the domain of f inverse. You just need to replace f of y, f of x. Replace this f of x by x. Now the next part. Find an expression for g of x and state the range of gf. Gf is very simple. You need to replace x of g by f. This is the x of g. You need to replace this by f. You need to replace this x by f. And f is this. So this is the function g fx. I just wrote plus 0 here in order to write the range of this function. We discussed these things in detail in reciprocal functions lectures. The smallest value of this function is 0. And we have to put minus 1, this value here. So when we will substitute minus 1, which is the domain of f, here we'll get this value, 1 upon 9. This is the maximum value of composite function and this is the minimum value of composite function. Therefore, the range will be 0 to 1 upon 9. You should watch my lecture of reciprocal functions in order to understand these things in detail. Question number 10. The coordinates of 2 points A and B are. Show that the equation of perpendicular bisector of AB is this. This is the rough sketch. This is A and this is B. This is the perpendicular bisector of AB. We need to show the equation of this bisector. Number 1, we need to work for the midpoint because bisector always passes through the midpoint. So the midpoint of AB is this, minus 1 comma 7. Now work for the gradient of AB. The gradient of AB is 2 upon 3. Therefore, gradient of this perpendicular bisector must be minus 3 upon 2. Now we have the point, we have the gradient, we can easily get the equation of this bisector. This is the required equation of this bisector. Next part, B. A circle passes through A and B. This is the rough sketch. Circle passes through A and B, and this is the bisector. And its center lies on this line. This line. So the center of this circle lies on this line and on this bisector. Because you did this property in O levels that from center to chord, the line is bisector. So this perpendicular bisector passes through the center. So we can get the equation, we can get the coordinates of C, the center of this circle, by solving these two equations simultaneously. So this is equation number 1, this one, and this is equation number 2. By solving these two equations, we have the coordinates of center. And this is the radius, AC, which is 13. Hence, this is the equation of this circle. This is the required equation of this circle. Let me explain this thing. You did this in O levels, that if this is the chord, then from center to chord, line is always bisector, perpendicular bisector to chord. I use this property here. Next question, number 11. The diagram shows part of the curve with equation and the line OA. A is the maximum point and B is the minimum point, and A and B are positive. Show that B is 3A. This is simple by differentiating this equation with respect to x and equating gradient to 0, we can get the values of x. So we have xb and xb upon 3. At A, x is A. At A, x is A. And at B, here x is B. At this point, x is B, and at this point, x is A. So this is A, and when you will replace this x by A here, you will get 3A is equal to B. You just need to replace this x by A, because x at A, x is A. Now we need to find the area. Show that the area of shaded region, which is area under the curve minus area of this triangle. This area can be found by subtracting area of triangle from area under the curve. So this will give you area under the curve, 11A power 4 upon 4. The limits are 0 to A. This is area under the curve, and you can get area of triangle. At XA, this is the equation of y. When you will simplify this, you will get the y coordinate. Y coordinate is 4A cube. So half base into height. This is the area of triangle. Now you need to subtract this from this area to get the required area. This is the required area, and you need to compare this area with this area. When you will compare these two areas, you will see that K is 3 upon 4. Well, this is all. An important advice for me and for everyone: be well-mannered. Good luck to everyone. And I am extremely thankful to Miss Umama, who helped me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. Ameen. May Allah Pak give her the best grades. Ameen. Allah Hafiz.